Hi, and thanks for joining me for the Qantas pilot briefing provided by Air Services. My name's Nathan. I'm an aviation communications specialist with Air Services. Prior to that, for approximately 6 years, I was an air traffic controller, and prior to that, I completed my Bachelor of Aviation at Griffith University and my private pilot license. Today, we're going to talk about an overview of Air Services. We're going to talk about One Sky, which is Air Services' project that's been in the works for quite a few years. The differences between en route, TCU, and tower controllers. SAR time management. SAR watch. And what happened recently, the lowering of Class E airspace. So, who are we? We're a government-owned organisation formed in July 1995 when the Civil Aviation Authority was split into two separate government bodies, Air Services Australia and the Civil Aviation Safety Authority. We manage 11% of the world's airspace, more than 4 million flights per year. We have approximately 3,500 staff that are employed with Air Services, 1,000 of those being air traffic controllers approximately. Why do we exist? We exist to provide safe, secure, efficient, and environmentally responsible air navigation and aviation rescue firefighting services to the aviation industry. What do we do? Air traffic control is what everyone knows that we do. We also provide flight information service, search and rescue alerting service, infrastructure and engineering through runway lighting, VHF comms, radars, nav aids, and the like. We provide aviation rescue and firefighting services, environmental regulation and monitoring, aeronautical information, AIP, and safety promotion and investigation. Our facilities. We have two main air traffic control service centres, Brisbane Centre and Melbourne Centre. We have two terminal control units in Perth and Sydney. We have 29 control towers and 26 aviation fire stations. Two air traffic control service centres, Brisbane and Melbourne. This is 11% of the world's airspace, and this white line dictates Brisbane from Melbourne Centre. So Brisbane do about 5% of the world's airspace, Melbourne do about 6%. I've got a little bit more ocean up here. And this white line here, this little bit here, is 60 nautical miles north of Sydney. So 60 miles north of Sydney, running through the centre of Australia and up somewhere near sort of Headland, Craftbury area. To compare our airspace to Europe, you can see obviously there's a big difference in densities, and then comparing us to America. So it is a very large airspace that we are in charge of. This is our Melbourne facility. So we have our Melbourne TAT Centre, so Melbourne Centre here. We also have the Melbourne Control Tower, which looks after Melbourne Airport. And then we have training facilities, admin, engineering, and so forth, all in our Melbourne facility there. This is our Brisbane facility. We have our Brisbane Tower. We have our Air Traffic Control Centre, Brisbane Centre here. And then this building here, if you drive past anytime now, this bottom section has all been demolished, and a whole new building is being built from about halfway onwards. And that will have One Sky, our new air traffic control system, will be housed in there. Where do we operate? So as I mentioned, two terminal control units in Perth and Sydney. We do also have we have a total of 7 terminal control units. These two are located at the airport underneath the tower, where the other ones, in Brisbane Centre, we have Brisbane TCU and Cairns TCU. And then in Melbourne, we have Adelaide, Canberra, and Melbourne TCU housed there. The 29 control towers, as I mentioned before. So this map shows the location of all of them. Obviously, they're quite heavy in what we call the J curve, which a lot of our traffic, some of the busiest routes in the world even, I think Sydney to Melbourne is top 3 in the world. Now you'll notice that if you look, say, somewhere here like Townsville or Darwin, we don't have a tower there, and that's because that's operated by the RAF. However, if you go across to our 26 aviation fire stations, you'll notice again very heavily on in the J curve, but we also do have Whitsundays Coast, so Proserpine, Townsville, Darwin, and some of the areas you may not think of, Newman, Ayers Rock. And the reason we provide a aviation rescue firing service and not a tower is because the traffic levels there don't necessarily dictate the requirement for a tower. However, the type of aircraft that go in require a certain level of aviation rescue and fire safety for the aircraft and passenger safety. Now let's talk about One Sky. The One Sky Australia program, it's the most complex transformation of air traffic management in Australian aviation history, delivering over 1.2 billion of economic benefits to airspace users. It's a partnership between Air Services and the Department of Defence. One Sky will replace the current independent civil and defence air traffic management system with an advanced integrated system known as the Civil Military Air Traffic Management System, CMATS. This is a short video that will talk about One Sky and the benefits that it will provide.
We have some of the world's busiest air routes here in Australia. Every year, air traffic arriving into and out of our airports greatly increases. And it's predicted to continue. So we're getting ready. The way we manage Australia's airspace is about to change. For the first time, controllers will use one civil and military air traffic management system to manage our vast airspace. We're optimising solutions such as long-range air traffic flow management and collaborative decision-making, so Australia has a more predictable and seamless air traffic network. Which is good news for passengers too. Here's how it works. We'll use the advanced technology and capability of our new air traffic management system to give airlines more airspace flexibility, to fly the most efficient routes for their aircraft. Pilots will have information early and the airspace access they need to avoid upcoming weather systems, making for smoother and safer flights. When it comes to managing delays, our improved air traffic flow management system will give us more predictability and more detailed information sooner. So we're more able to integrate international flights into our busy domestic network. And through airport collaborative decision-making, we'll have synchronised operations. So everyone will be working with the same information about what's happening on the ground and in the air. It means pilots will have the right information at the right time, so they can make informed decisions that are best for their flight, meaning flights arrive and land on time. It's about making sure Australia's prepared for whatever lies ahead in the future of aviation.
We hope you've enjoyed your flight with us today. We've enjoyed flying with you.
Okay, so that's our One Sky program. So you can see here, this is our current system, our TAT system. And just quickly, this screen down here is our VCS. That's our communication system. So that allows us to call other controllers, TCU, tower, shift managers, and so forth. We have our weather radar here, but we can also look up procedures and aircraft information there. Then we have our main ASD screen, and basically in the middle is where the aircraft, the controllers area would be, and then they would control all the aircraft that are in their airspace, and then around the side would be it's darkened out a little bit, and that's aircraft that will be coming to them. So they'll see green tracks, so the ones that they are in control of, and then blue tracks that are coming to them. And these boxes here can all be moved around the screen and provide information about the aircraft that they're in control of or that they'll be getting shortly. This screen over here on the right, that allows us to show weather information, other strips that may be that haven't quite yet taxied yet, haven't actually gotten into the air, and then generally a bigger version of the map that's on this screen here. And so what that map will be is it'll be zoomed out quite a few more levels so that you can get a bigger picture of what's coming, so that once you've scanned around your screen, done everything, all your outstanding actions, you can look over here, look to see is there anything coming that you're not expecting that might be slightly different, and give you more time to plan how they're going to transit through or land within your airspace. Conversely, this is an artist's impression of what one sky will look like. You can see it's a lot more clean and simple, just a single screen. And so all the controls will sit around on these outside computers, and then in the center here will be an ops manager or an aisle manager that looks after that. So the next thing we'll talk about is the areas of responsibility. So most people would know that there's three types of air traffic controllers. Most people would think of just tower controllers. When I was a controller, everyone would think that I would go and work up in the tower, but we also do have TCU and en route controllers. So I'll show you this small little video now.
Three different types of air traffic control that we have. The one everyone would be most familiar with is the tower environment, so the control towers that you see at the various airports around the country, and that's where you're controlling just the environment of the airport itself. At the major capital cities, the towers don't actually have any airspace at all, they're just responsible for the runway. The next type of control is what sits immediately above that, which is approach control. And radar approach control uses radars and looks at the blips on the screen, which is what people are familiar with from movies, and keeping all the aircraft apart on a radar screen. Once you get outside of that area, which is generally about 80 kilometres from the airport, that's actually en route control, which is one that people know the least about. From Melbourne and Brisbane, we've got two buildings, and we do approximately half of the country each. And they do all the areas that are outside of 80 kilometres from our major airports and the regional airports that have got their own control tower services. And those en route sectors comprise the vast majority of the controllers that we have.
So we'll just talk a little bit more in depth about that. So we'll talk about tower. So obviously out of all three types of controllers, they have the best view. They can actually see the aircraft they're talking to, see them land, take off, and also look at the beautiful view that they get up there. So the three main endorsements that they have in the tower is the clearance delivery controller. Now they're usually the first controller that you'll speak to. They'll send you your pre-departure clearance, which they will have coordinated with the TCU, or that's the control unit that will sit above the tower. And they'll give you airways clearance. Then there's the SMC, or ground. They're responsible for controlling aircraft from the apron to the runway. So pretty much from the time you are ready to push back, right up to the runway holding point, they will be in charge of your flight. They have stop bars that they can use at runway intersections, and they can do that. The next type is the aerodrome controller. They're responsible for runway separation between arriving and departing traffic. They use runway and weight turbulence separation standards. At Metro D aerodromes, they also own the circuit area and airspace within the control zone. It's roughly 3 nautical miles and up to 2,000 feet. At some Class D aerodromes, the ADC might request an airspace release with the relevant ATC sector for circuit training, for airwork, and they'll provide the separation in that airspace. Depending on the traffic levels, any of these positions can be combined, and at some towers that we call one-person towers, there's only one person on the shift that do all three of these roles. At busier towers, these positions can all be split, and even the aerodrome control can be split into two. If there's parallel runways, there may be a north and a south controller. Then moving on from the tower, once you've left the tower environment, you'll be handed over to the terminal control unit, and they're responsible for the next stage of flight. So once you leave the runway, you'll be transferred over to departures, who will facilitate the sequence of traffic in and out of major aerodromes. They also have transiting aircraft passing through, as well as students doing practice instrument approaches, the ILS calibration aircraft who does multiple approaches, and any other number of itinerant aircraft. Then there's the high priority aircraft, such as medevac helicopters that land and depart from major hospitals. Then in places like Melbourne, where Essendon is only 3 or 4 miles away, they're sequencing arrivals and departures to 2 aerodromes at once, and all of that traffic has to be separated safely, so the approach controller can have a very high workload at times. To make it a little bit easier, we use a sequencing tool called Maestro, which allows the TCU to plan their arrivals. It considers vast amounts of information, such as weather, aircraft types, speeds, traffic levels, flight plan routes, in order to set slot times for arrival of aircraft into major hubs, which is why it's so important that pilots meet their COBT time, calculated off block times, so that as best as they can limit the delays that are into major aerodromes. Once you're outside the TMA, you'll be transferred over to Brisbane or Melbourne Centre, which are where our en route controllers are, the majority of the controllers that we have in the company. As we've spoken, the Australian FIR is divided into 2, Brisbane and Melbourne, but within that, they're also split into small little sectors that each controller is responsible for. It may have its own frequency, and the controllers can put multiple sectors together and control multiple sectors if it's quiet. So, say overnight, or during the day when it's busy, they would just control one particular sector at a time. So en route controllers provide a separation service for all aircraft in controlled airspace. They provide separation for arrivals and departures into non-towered aerodromes. They ensure separation for you to divert around weather and around military, restricted and danger zones. Depending on the level of navigation equipment you have on your aircraft, such as ADS-B or ADS-C, this will determine the separation standard used by en route controllers. Generally, the better the equipment, the more accurate the radar picture, so the aircraft can be allowed to pass more closely, which improves the efficiency. En route controllers are also responsible for search and rescue alerting for IFR traffic, which I'll talk about later on. They also hold overwater skeds or optional reporting times for our waterfall control aircraft. We also have 10 international FIRs that adjoin our airspace, so our en route controllers coordinate traffic into and out of the Australian FIR with those adjoining sectors. Outside controlled airspace is a bit different. As a separation service can't be provided, en route controllers will provide a directed traffic information, which will alert them to all IFR and any known VFR aircraft. So that's basically our 3 main groups of air traffic controllers. But we also have another team that pilots frequently will interact with, and that's the SAR time management team. So we'll talk about who provides the SAR time service, where your SAR time is held, what happens if you don't cancel your SAR time myths, and how we can work together to reduce the SAR times. So, who provides the SAR time service? The Brisbane Airspace Services High Frequency Unit, HF unit. We're located in the Brisbane Centre in the Ops Room. The HF unit is staffed by aviation communications specialists. There are around 50 of us in our team. And we provide international and domestic communication services across the entire Australian FIR. This includes third-party communications or relay service, in-flight information such as weather, SAR alerting for IFR and VFR aircraft, and SAR time management. This map shows the boundaries of the HF sectors, where the airspace is divided into around 50 ATC sectors, all through here. There are only 3 sectors for domestic, 1, 2, and 3, whereas for international, there's 3, 1, 2, and 3. It's not usual to combine these sectors. It's not unusual to combine these sectors. So, for example, on a night shift, we might have 1 domestic person doing all 3 sectors and 1 or 2 international people doing the international role, depending on what traffic we have. So here you can see our HF domestic team, which is 3 domestic HF roles and 1 for SAR times. This shows our 3 international positions. And then moving over to this map, this shows the search and rescue region that Australia is responsible for. It's roughly 1/10 of the Earth's surface, or 53 million square kilometres. So where is my SAR time held? So when you submit your flight plan to NAPES or another flight planning software, the SAR time goes to our central SAR time database, or sensor. It's separate to NAPES, so changes that you make to your SAR time over the phone won't be reflected on your flight plan. SAR times is primarily a phone-based service, so you can make changes or cancel your SAR time on VHF or HF or through your flight planning software. Most of the SAR times we hold are for VFR aircraft, though IFR flights can lodge a SAR time for departure if they've landed in a remote area. The SAR time roles has a dedicated staffing during normal business hours. Outside of business hours, we're currently managing the role from our other domestic HF units, our HF positions. This is what our sensor database looks like. You can see it's very basic. It's really just like a clever clock. You can see all the SAR times listed in time order, right here, with the soonest one at the top. If you change or cancel your flight plan through NAPES, we'll receive an AFTN message that we manually change and cancel every single SAR time through. And if you forget to cancel your SAR time, an alarm in the top box, and that's when we'll know to start calling you. SAR times not being cancelled is one of our biggest concerns. It takes a lot of time to chase up and shifts our focus from our other duties. As soon as we get an alarm, we'll start calling you. Ideally, you'll answer on the first ring, tell us you've just landed and we're about to call. But failing that, we'll talk to the responsible ATC sector. They'll try calling you on VHF. We'll then try calling you on HF. And if your destination is a towered aerodrome, we'll call the tower to check if you've landed. If after all that we still can't locate you, we'll keep trying for up to 30 minutes. And at that point, we'll declare an uncertainty phase and the transfer of responsibility to the Joint Rescue Coordination Centre, JRCC, to commence search and rescue action. This happens more often than it should. Some SAR time myths. Some myths we've heard pilots say about SAR times. That it doesn't matter if you don't cancel your SAR, that air services will call you anyway. Well, yes, we will call you, but we should only be calling you if you're actually in trouble. It is the pilot's responsibility to cancel their SAR time. That air services will give you leeway before calling. That's incorrect. We will commence communications checks at the time of your SAR expiry. That your SAR time should be the same as your ETA. This isn't ideal. You need to allow yourself time to taxi, shut down, do your paperwork and get back to the office. We'd recommend SAR time plus 30 minutes after your ETA. I can't change my SAR time if I'm already flying. You can always amend your SAR time with ATC on the area frequency or with FlightWatch on HF. It's not the preferred method as it does increase ATC workload, but it's much better than letting it expire, which increases everyone's workload. Forgetting to cancel my SAR time doesn't affect anyone else. Well, it's already affected the SAR times unit, ATC, Tower, and even the JRCC, who work with maritime safety, federal, state police forces to locate you. So there's the possibility of shifting focus away from an actual emergency. And here's a real-life example of that. On the 9th of July 2019, 10 SAR times expired. 2 pilots were unable to be contacted. All 10 aircraft had in fact landed safely. However, at the same time that this was happening, an actual emergency was occurring. An RPT, Fokker 100, departed from Geraldton and suffered a complete engine failure in one engine while en route. They declared a pan and continued on to land safely at Perth. JRCC were engaged during this incident, and whilst also having to locate they also had to locate the 2 pilots who failed to cancel SAR time as well. This graph shows how many SAR times are lodged with us each year, between 110 and 130,000 each year for the last 5 years, and we're on track to do the same number this year. This shows how many expired and went to communications checks, around 9,000 each year, and how many referred to JRCC, between 400 and 800 each year. This is a lot of man hours chasing up pilots who have just forgotten to make a phone call. So what are we doing to reduce this number? We're sending out educational material to flying schools. I hope you've seen them up at your school. We're sending out performance reports showing each operator their total number of comms checks each month. There's lots of information online, and we have a dedicated email address for general inquiries or operational questions. This is an example of the performance figures we send out to flying schools. This is the top 20 worst offenders for 2019. You can see the number 1 spot is hard to beat, with over 1,000 expired SAR times for the year. So, how can you help? Make sure you set a realistic SAR time to allow yourself 30 minutes after your ETA. Get everything sorted. Set an alarm on your phone, SAR time minus 5 minutes, as a fail-safe in case you do forget. Remember, you should only have 1 active SAR time for your aircraft. So if you have multiple legs and you want a SAR time on each leg, set it as TBA on your flight plan and cancel and set the new one after each landing. Consider leaving a flight note with a responsible person. If you're going out to the training area or doing a short NavX within your local area, consider whether a SAR time is necessary and maybe a flight note is all you need. And as always, make sure you use correct phraseology when you call to cancel your SAR time. Tell us the correct call sign and tell us the SAR time you nominated when you're cancelling it. We have to ensure that these both match so that we don't inadvertently cancel the wrong one. So we'll talk about SAR Watch now. The SAR Watch is a generic term that covers SAR alerting based either on full position reports, if you're operating over the ocean or out of radar coverage. We'll rely on the positions that you give us, and that's what we'll use for our SAR. Otherwise, scheduled reporting time, so ops normals every 30 minutes, or SAR time, as I discussed before. We maintain SAR Watch for all aircraft subject to an air traffic control service in classes A, C, D, or E airspace, IFR aircraft in Class G airspace, VFR aircraft on request, and in TIBA airspace where capability permits. So TIBA is Traffic Information Broadcast Advisory. So in the event where multiple controllers are sick or unavailable and a particular piece of airspace needs to be declared as TIBA, there's no service provided in there, but if there's people around that can provide, they can provide a SAR Watch in that scenario. We maintain SAR Watch via continuous visual, so binoculars in a tower, or surveillance, radar, ADS-B, or by a time nominated by ATS or a pilot, which may include an estimate, so estimating Corky at time 03, that would be our time, a no-com time, these are for military low-jet pilots, so they'll go and do a low-level flight, and before going low-level, they'll nominate a no-com time, and we'll use that for their SAR Watch. A time to report, such as a SCED, 30 minutes, or an ops normal time. So this is what we use for our emergency phases and time sequence. So this column here is commence communications checks. So if we go right down to arrival or departure having nominated start time, at the start time, we're required to commence communications checks. And then after 30 minutes, we'll declare an uncertainty phase. Other ones are different. If we give you a frequency change, 3 minutes. If we're calling you and you're meant to be maintaining a listening watch, 3 minutes. Arrival at a non-controlled aerodrome, 10 minutes after the estimate you've given us to land. And this is when we would declare an uncertainty phase. Within this time period, however, if any information comes to hand that there's smoke or someone saw an aircraft descending rapidly, a report from the public, something like that, we can declare a phase earlier, and we can also move it up to an alert phase or a distress phase. But these are just a guideline that we work with. So ways that we'll commence our communications check. So we'll contact the pilot directly by calling them on the normal or alternative frequencies. We'll be repeating the calls with discretion, calling them often, using the previous frequencies, the next frequency we might think they're on. We'll ask another pilot to try and call them on VHF or HF, on 1215, on numbers. We'll ascertain whether the report's been received by another unit and perhaps they've been too busy to pass it on. We'll arrange for other ground units to call the pilot on normal alternate frequencies, and they'll let us know if they haven't received anything within 5 minutes. So other possible implications. So once we've handed this over to JRCC, then they have the power to, and sometimes we'll help them with this, to ask the Royal Flying Doctor Service, military aircraft that are flying around, commercial and private aircraft. I've had a Dash 8 that was landing at Gladstone that was asked to fly low level just off the coast because there was a beacon report, and they didn't have someone immediately available to be tasked, and they wanted to see if there was any sign of a lifeboat, a capsized boat or anything like that, while they got marine vessels and rescue helicopters tasked to that job. So they may all be asked to redeploy and go and conduct that initial SAR reaction. So once a phase is declared, it will be handed over to JRCC, who will then continue the response. So they will escalate it. They will involve the police, authorities, those sort of things. They can also ask us to ask aircraft, can they do this or that? And we're still involved with it in a smaller capacity. They're responsible for it. So talking about JRCC, the Joint Rescue Coordination Centre, they operate 24/7 from their head office in Canberra. They're responsible for approximately 7,000 incidents per year. They coordinate maritime, aviation and beacon-related incidents that fall within the Australian SAR region. They manage and operate the Australian ground segment of the COSPAS SARSAT distress beacon detecting system. So the newer ELTs, if they're activated and the satellite passes over, it can actually pick up the distress signal instead of relying on pilots to listen on 1215. They coordinate medical evacuations, broadcast maritime safety information, operate the modernised Australian ship tracking and reporting system, ASTRAP. They do quite a few things. So the last thing we're going to talk about today is the lowering of Class E airspace. This was conducted back in May, and so this was before the introduction of that. So what we're talking about is continental airspace. So your high density, that would be on your J curve on the coast, and then moving across to your continental airspace, which normally Class E would start at flight level 180. And what we've done is reduced it down to flight level 125. Sounds like a small change, but that bit of airspace there requires a lot more separation and does increase our workload. It was completed on the 21st of May this year. And the benefits of this is that it increases the availability of controlled airspace services in the Class E airspace for instrument flight rules aircraft. It reduces IFR pilot workload of self-separating in Class G using directed traffic information from controllers. So the level of service that IFR pilots will receive is enhanced. It removes the variation of Class E across Australia, makes it a little bit more standardised. It improves notification requirements for high-level parachuting jumping in Class E. So it requires the parachute companies to give us more notice. There's more restrictions with that, which allows us to separate aircraft more efficiently and safely. It provides industry and their customers assurance of enhanced safety and controlled airspace when compared to Class G airspace. And so that's all that I have for you today. I want to thank you for taking the time to view this presentation. If you do have any questions, please feel free to let us know, and we'd be happy to answer those. And also hoping that in the future, once COVID has settled down, that we'll be able to have you back in the Air Traffic Control Centre. So thank you very much and have a good day.